All right, everybody. So here we are, our next big lesson on similarity. We talked a little bit in class last time about dilations, scale factor, and the center of dilation. So what we're going to do today is extend that idea a little bit further. So the two things I want you to keep in mind for this video are the kind of the two main methods of solving these similarity problems: the scale factor method and the proportion method. So the big idea, this proportion method, is going to end up being a little bit easier, especially when there's decimals involved, when there's not like a really nice, easy scale factor to identify. So let me show you what I mean by that. Looking at this question here, first of all, we want to identify, are these triangles similar? So is there a dilation that happened? And the fact that these two angles and these two angles match up, it tells us that yes, there was a dilation that occurred. So we know that there's a scale factor that took one triangle to our other triangle. In these cases, it doesn't really matter which is the new and which is the old. I know we talked about that a lot last class, new divided by old. But if it doesn't specify it and we're just looking for a missing piece of information, so if you look in this example, I'm asking us to find the measure of that missing side, it doesn't really matter which is the new and which is the old. So what I'm going to show you here, I guess, why don't you try this one on your own just for a second? So please pause now, see what your approach would be to find this missing side. And then when you're ready, you can unpause it. So please pause now. Okay, so hopefully what you identified is that you saw there was a correspondence to the 8 from the 8 to the 12, and there's a correspondence from the 6 to the 9. There's some scale factor that's taking us from one side length to the other. So remember, it's not addition. We're not doing an adding operation to get from one side to the next. These are all about multiplying. It's all about scale factors. So if I look at the 6 to the 9, and I want to figure out what my scale factor is, what I'll do is I'll do 9 divided by 6. 9 divided by 6 is 1.5. There's my scale factor. So now all I need to do is apply that scale factor from each of these other sides. So we can kind of check. 8 times 1.5 is 12. That checks. And now to find my missing side, I can apply that same scale factor. So I can take what I have, I can multiply it by 1.5, and that would give me an unknown, a missing side of 21. And that is the correct answer. So the scale factor method is really helpful when we have a nice, easy number to work with. Here's the other thing that we're going to talk about today. When I use that word proportion, what it is, it means we are setting two scale factors equal to each other. So I guess I should have mentioned, this is not in your notes. This is just kind of an introduction, so please don't panic and look for this in your note packet. So we're going to set two scale factors equal to each other. So in this case, I could do a couple different things. I could say 9 is to 6, so that's my scale factor for these sides, is equivalent to 12 over 8. And that's true. 9 divided by 6 is 1.5. 12 divided by 8 is 1.5. So that checks out. Those scale factors work out. That means kind of we had the right idea. But now that we have this unknown, I can put that unknown side into my proportion, into my scale factor. So let's use the same example we did up here. So I'll do this over here on the side. So if I say 9 is to 6, that's the scale factor that I know. I can basically say I want that scale factor to match up to my unknown scale factor. So if I say 9 is to 6, I know that has to give me the same scale factor as whatever x is divided by 14. All right, so that's the idea. So now we can do our cross product, our product of the means and the extremes. I know some people call it cross multiplying, but what we really can do is use our knowledge. We say that, okay, 6 times x. So if I multiply the product of the means, so I know 6 times x is equal to 9 times 14. So if I'm going to do this in my head, let's see, 14 times 10 is 140, and then that means 14 times 9 is 1 less than that. That's not right, is it? No, 126. I was backwards. And now I can divide both sides by 6, and I get x equals 21. So I get the same answer whether I use the scale factor method or whether I set these two proportions equal. And the great thing about the proportions, we're going to talk about this in a second, is that I can use the proportion in any combination of sides. It doesn't have to be any specific pair. It can be any combination of the sides that I'm going to use my scale factor for. So I think you'll see what that means in a minute. So into your notes, this is, I believe, I don't have a page number on mine. Find the 6.2 section of your notes. So if you need to pause for a second, you can go ahead and do that. You don't need to write these 2 points at the top. I have these written in your notes, but I wanted to make sure they stood out a little bit. So to solve for missing sides of similar triangles or any similar figures, we first need to determine that the triangles are similar. And the easiest, most efficient way to do that is by showing that the angles are the same, just like I did in the last example. So if the angles are the same, it means that the triangles are similar. There was a dilation. And then we're going to use either the scale factor, so the new divided by the old, which we did last class, or this new idea of proportions. Well, not a new idea, but new as far as this stuff we're learning now, proportions to solve for the missing pieces of information. All right, so we've now seen that when a figure is dilated, all the side lengths are scaled according to a scaling factor, and the angle measures are preserved. The angles don't change. So these figures are the same shape but different sizes, and that's kind of our main definition for when things are similar. All right, and our symbol for similarity is just like a congruency. It's just without the two equal signs below it. So there's our symbol for similar, right? That's a big one we're going to need to identify. All right, so figures are similar if their sides are proportional and the corresponding angles are the same. So looking at this question here, we're gonna kind of skip letter A. I'm gonna tell you that these are in fact similar. So let's say we can make these angle markings here. So those angles are the same, and let's say those angles are the same. So that gives us our similarity transformation. So we're going to be looking for the missing sides. So let's just call this x. All right, so solve for the missing sides of the triangles. So we'll look for this one first. So the first thing that we can do is we can use the scale factor method. This one's actually very straightforward. It's a nice whole number. So the two pair of sides that I know the 7 is mapped onto the 14 using this dilation, this scale factor. And we can easily look at that. 7 times 2 is 14. So using the scale factor method, I know my scale factor in this question is just 2. So if I'm looking for side x here, all I need to do is take the 8, apply my scale factor, times 2. So 8 times 2 is 16. That's an easy one. My side there, my unknown, is 16. So let's use the proportion method. All right, let's use the proportion method to find this side. Let's call this side y. So we could absolutely just work backwards. We could do 20 and work backwards with my scale factor, and that's probably the easiest way in this example. But if we were using the proportion method, I'm going to say that, okay, I know that my scale factor, I know those two sides are related. So I know that the scale factor, 7 is to 14. That scale factor has to be exactly the same as it does between these two matching sides. So as it does between y and 20. Now, the great thing about the proportion method is that there's other ways to set it up. So let's say I didn't do 7 over 14. Let's say I started with 14 over 7. That's not wrong. We're going to get the same answer, but we have to be extremely careful. So if I say 14 over 7 is my scale factor, it doesn't make sense to do y over 20 here. That doesn't match up, right? That's not the same scale factor. If I say 14 over 7, I would have to match it up on the other side with 20 over y. And that would give me a good equation to set up. So now I can solve this out. We'd have 14y. It actually would be the same on either of these. So it's kind of neat to see how it matches up. I would have 14y equals 140. Same thing if I did this equation, 14y equals 140. Divide both sides by 14, and we would get y equals 10. And that certainly makes sense when I look at the scale factor of 2. Okay, so I hope that makes sense. We're going to have a lot of time to practice this in class. I think we're going to do some of this together next time. This will probably be our classwork. But I want you to set up this question here. So I want you to try to do it using the proportion method. So again, this isn't in your notes, so if you need to pause for a second, go ahead. This is a little typo here, a little stray mark. Let's get rid of that. So I have two triangles. I know the angles are the same, so I gave you that information. So that tells me that these triangles are definitely similar. So what I want you to do is I want you to solve this out using the proportion method. So if you look real quick, you know what? Let's make this even a little bit harder. Forget that. Let's say this side was 11. If I wanted to use the scale factor method, it's not impossible. I could use my calculator. I would have a decimal. But if I did 11 divided by 4, that would give me a little messy of a number to use as my scale factor. So on my calculator, if I did 11 divided by 4, that would give me 2.75. So actually, it's really not that bad. I could have made that harder on you. But if the scale factor comes out to be a decimal or anything that you just don't want to work with, I think this proportion method is really a nice way to solve it. So go ahead and start it now. See if you have an idea of where to go with this. And then when you're done, if you're not sure, you can unpause and I will walk through it with you. So go ahead and do that now. All right. So like I said, the great thing about these proportions is that there's a lot of different ways to solve it. So let's say I did what I just showed you a minute ago. If I said 11 is to 4, so that's scale factor 11 over 4. For this equation to work out, for that missing side to be correct, I would have to match it up with the scale factor of x over 9. And then I could do my cross product, I could solve it out, and I would get my answer. I could also set it up the other way. I could say 4 is to 11. So the scale factor of 4 divided by 11 would also work. But I would have to match that up with the scale factor of 9 over x. All right, so you can see the same setup, I guess the same equation just set up a little bit differently. So as long as you're making the scale factors match up, as long as you're creating those equal scale factors, you're going to have a correct, kind of a correct equation. So now if I do my cross product, either one of these is going to give me 99 equals 4x. Divide both sides by 4. And I get my unknown side equals 24.75. Okay, so that's how we're going to set up these problems for next class, and we're going to take it a little bit further. But that's the main idea. So please let me know if you have questions, and be ready for those entry ticket skill checks that we talked about. All right, we haven't done one for a little while, but I will be prepared for that. All right, guys, I'll see you next time. Have a good day. Bye.